Alright, I think I'm recording. I just heard a bunch of firecrackers or cannon or something that go off. About jumped out of my chair here. Kind of woke me up. Maybe that's kind of good. It gave me a little bit of adrenaline. We have this problem number 12, which I think is our last problem. This function is the parent function of a square root function. I see three transformations on that square root if I want to think about the graph of f. My square root function. Look, a terrible sketch is something that looks like this. It's hard to freehand. All right. The plus 1 shifts to the left 1 unit, so this is negative 1. The negative sign reflects across the x-axis, so it's a mirror image. It's now looking like that. It's reflected across the x-axis. And now this green goes down 2 units, so it goes down here to negative 2, and this point comes down and it looks like this. Alright, so a couple things I want to get from this sketch. I want to recognize this endpoint here. The coordinates of it is negative 1 comma negative 2. I want to recognize that the domain, all of the x's, if I look at points on this graph, every point has an x coordinate that is bigger than or equal to negative 1. All of the y coordinates on this graph are below negative 2. So this y coordinate is less than negative 2 because it's below it. This y coordinate, and so forth. They're all less than negative 2. Okay. Since this graph passes the horizontal line test, that function is a one-to-one function. And one-to-one functions have inverses that are also one-to-one functions. Alright? So let's find the equation for the inverse, which we know is going to be a one-to-one function. Now, I'm going to erase my sketches here. And I'm going to not use function notation for a few minutes. I'm going to use x and y. So I'm just going to make this a y. So the idea of an inverse changes the domain and range, which in the equation we're going to change the variables x and y. Not only am I changing the variables in my equation, I'm also changing over here because this describes the domain and range. Well, now the range is bigger than or equal to negative 1, and the domain is less than or equal to negative 2. I need to solve this equation for y. On the right hand side, I see two terms, and the term of interest that contains my y variable, I need to get it by itself. So I'm going to add 2 to each side. X plus 2 is equal to the opposite of square root of y plus 1. Well, that negative sign, I'm going to change the sign of every term in this equation. The x, I'm going to change its sign. The 2, change its sign. This is positive. And have it like that. To get rid of the radical, I'm going to square each side. I'm going to write this on the left hand side, y plus 1. Well, with both of these being negative, and when I square a negative it's positive, I'm going to change this negative x minus 2 to x plus 2 quantity squared, because I don't want to work with those negative signs and make a silly error again, especially since it's getting late on Friday. I almost have this y by itself. If I subtract 1, I've got x plus 1 squared minus 1. Well, hey, I recognize this as a quadratic function written in vertex form. Now, remember that for each step I had these restrictions coming on. So let's come down and write them. Y greater than or equal to negative 1 and x less than or equal to negative 2. So let's think about what this graph looks like with these constraints. Without the constraints, hey, this is a parabola that opens upward. X squared sits at the origin. The plus 2 is going to shift to the left 2 units. The minus 1 is going to shift down 1 unit. So the coordinates of this point, left of 0, 2 to the left, made the x coordinate negative 2, 1 down makes the y coordinate negative 1. Now, it's telling me that it wants the values of x that are less than or equal to negative 2. Here on the left-hand side, every point on that graph to the left of the vertex has an x coordinate that is less than or equal to negative 2. And look, the entire graph has all the y coordinates greater than or equal to negative 1. So I don't want any points on my graph to have x's that are bigger than negative 2. So that means I've got to come down here and erase that from that's not on the graph for this function because we restricted the domain. Well, we knew that from the original graph that it was a one-to-one function. We now have an equation for its inverse, and we know this inverse is a one-to-one function. Now, on some of these previous equations, I could drop the restrictions, because they were automatically implied but with the square root. Well, here, I can't. If I drop that restriction, that's going to bring back the right half of this graph. I need people to recognize that it's the left of the axis of symmetry. So every point is y greater than or equal to negative 1, even with the original. I don't need this restriction for p. I need to tell people what the domain of this inverse is. So this is my final answer this time, and it's crucial that I keep that x less than or equal to negative 2. I can come in and use my function notation. Let's go back and see what it was f. So I can write this as f inverse of x is this parabola with a vertex at negative 2, negative 1, but I'm interested only in the part of the parabola that's left of the axis of symmetry. So I have to tell people that. There's my final answer for number 12, and I think that's it for these problems. So I will talk to you later, and I hope this helps.